All right. Good afternoon to most of you anyway. Noontime for those of you on the West Coast. But I'd like to thank everybody for coming in and taking part in our presentation on Pro Heat 2.0. And special thanks today, as a lot of the big brewery conferences were canceled this year. We thought it was a very innovative idea by both Stout Tank and Kettle and Brewmation to sponsor this event. And we're very proud as a longtime partner with this company to be a small part of it. Today, the presenters will be myself. My name is Steve Pretz. I'm the Vice President of Sales for Pro Refrigeration. I've only been with Pro for about 6 months now, but I have nearly 30 years experience with Pro Chiller, coming from the dairy industry. Pro was a very big supplier for us in the dairy business. It's just dairy and brewery is really where Pro Refrigeration started, and certainly proud to be associated with the company and getting to learn a lot more about the brewery business. Joining me today will be Damon Reed. Many of you already know Damon. He's our Chief Revenue Officer, and he is also the head of our Technical Services and Field Services Division for Pro Refrigeration. He also does a lot of the engineering work and was very instrumental in the foundation and development of the product we're going to talk about today. To start with, the concept of recovering heat, and you'll hear the term waste heat discussed. Simply put, what waste heat is, if you've ever went out to your chiller while the fan was running and felt all the heat coming off of the machine as your product gets cold, that's what we're talking about, waste heat. Heat is energy, and normally that heat goes into the atmosphere, but using this technology and this process, we're doing recovery of that heat and in the form of hot water, which can be used for a number of things. It's nothing new. The genesis of the business was from my background in the dairy business, starting in the 70s and 80s during the first energy crisis, when we were only 5 to 10 years from running out of oil. Nobody anticipated $5 oil at that time happening again, but a lot of research and a lot of development went into products that would create hot water on dairy farms. And hot water in anybody in the food business is very important from a sanitary standpoint, whether it's cleaning a winery, a brewery, a dairy farm, particularly in a dairy farm, controlling bacteria, and with very high temperature water. A large dairy will typically use 3,000 gallons of hot water a day. So that's the origin of it. It's not a new concept, but what we're doing now is scaling up for larger operations like large breweries, dairies, wineries, as well as meeting the need to reduce the carbon footprint of your business, as well as being good stewards to the earth here. So after the presentation, if you've sat through some of these before, the format's the same. You can ask questions in the discussion bar here on the side, and we'll get to those at the end. Also, if you have anything that can wait till the end, we have about 15 minutes of space reserved at the end of the presentation. And if you would really like to discuss the potential for this product or anything that we offer at Pro Refrigeration, we really encourage you to go to the VBC website and register for a one-on-one. That's really the best time to talk about specific things and actions that are really important to your business as well as ours. But at the end of this program, we'll be talking a little bit about maybe some general questions you may have that may be of interest to the entire audience. So going on from there, I'm going to hand it over to Damon, and he is going to discuss a little bit about how the system's constructed, what its capabilities are. Then after that, I'll talk about the economic case for the product. So take it away, Damon.
All right, great. Thank you, Steve. I appreciate it. So I'm going to start off with answering that question. What is Pro Heat 2.0? And what that is it's a system that we've developed that'll equip your Pro Chiller system to convert that waste heat that Steve mentioned earlier up to 140 degree Fahrenheit water. A couple of things just to kind of address before we get too far into it, but one thing is there's really no such thing as free hot water, and we don't make claims of free hot water, but we do guarantee that the Pro Heat 2.0 is significantly going to reduce your water heating costs by maximizing your chiller performance and recovering that waste heat effectively, safely, and efficiently. We estimate that the Pro Heat 2.0 system is going to recover up to 33% of the rejected heat and transform it into hot water. That hot water comes from energy that would normally be wasted. Just like Steve mentioned, we're taking all of that heat out of the brewery, we're moving it into the chiller system, and then we're discharging it into the air. So we're going to capture some of that. That's going to make you use less electricity or gas to make the same amount of hot water, which is greatly going to reduce your carbon footprint. The chiller system is our top priority. We aren't going to compromise the operation of the chiller system for the sake of generating hot water. For us, the chiller system always comes first. Other systems that are out there, they'll tend to operate at a higher condensing temperature in an effort to be able to capture even more hot water. The only thing that that's going to accomplish is higher utility bills and more stress on the chiller system. We do have a cost justification tool that'll guide you along the way to determining if Pro Heat 2.0 is the right choice for you. Steve is going to give us a great demo later on that, but also we have that available for one-on-ones or with your regional sales team that they could go through that with you. So we feel we're setting the standard in heat recovery. We're increasing efficiency of the system by reducing the load on the condenser of the chiller. We're also reducing the risk of thermal shock in the system, and I'll talk about that with the two-stage heat exchanger process we use. And the system can also be controlled and monitored using Elliott, our web-based industrial IoT platform also. So how does it work? And the center of the Pro Heat 2.0 is the two-step heat recovery process. In step one, the waste heat is pulled from the refrigerant. If you notice that heat exchanger 1 in the diagram, and then we transfer that heat into the recovery loop. That's our heat transfer fluid that's moving through there. Then we go into step 2, where we're using a second heat exchanger, that heat exchanger number 2, and that's where we're creating the hot water. That two-step method, that allows us to accomplish some very important things that aren't quite possible with a single-step heat recovery. One is safety. By separating that refrigerant from the potable water supply, we can protect not only the refrigeration system, but also your potable water supply from any contamination. It's on board, so everything's factory installed, and that enables us to safely locate the equipment outdoors. Even in extreme climates, we can provide a solution. The freeze protection on the system, our recovery loop utilizes a food-safe glycol-based solution that protects it from freezing. Combined with the effective insulation and smart flow operation, we deliver year-round, reliable operation of the system. It's serviceable. Low water quality is tough on heat recovery systems. I saw there was a boiler presentation earlier. We were talking about how that needing to have a blowdown on the water because it can get minerals and deposits into the system. By separating the heat exchangers into a two-step heat exchanger, what we're doing is we're eliminating those high expenses that can come from having to service a failure on the refrigerant heat exchanger, and we're just looking at the heat transfer fluid to potable water heat exchanger as a potential failure point. What that means is a lot less expensive repair project if something happens. You don't need to have specialized refrigeration tools to be able to make the change. You can essentially make the change with a pipe wrench and a bucket to catch with the fluid that drains out. On the process control side, the key to controlling that heat exchange is through the flow. Our dual fluid pumps enable us to turn on and off based on the demand for hot water. And that gives us just great flexibility. There's numerous opportunities to utilize the recovered heat beyond the water, and you can get in touch with us and we can talk about ways that you can take that water, move it into other sources of the system, of your system, and be able to utilize that heat for things other than just simply your hot water processes. With that, kind of the overview of how it works, that's where I'm going to go ahead and hand this back over to Steve. We're going to talk about the proper system sizing and some of the things that are involved with the return on investment of the system.
Well, that's great, Damon, and thanks a lot for that. And I think one thing I want to underscore is the general concept, and it's not only the concept for Pro Heat 2.0, but it's also the concept that we've had from the beginning for Pro Refrigeration. We developed chillers of various sizes, from 300 horsepower down to a fraction of 1 horsepower. However, they all have the same fundamental design: is a ready-to-go packaged system that allows you to not have to be a refrigeration expert. So what the big advantage that we provide, and it sounds complicated when you see what Damon goes through, but the big payoff is you don't have to tap into the refrigeration system and potentially damage it. When you receive the chiller, this system's on board, and any plumber, and in many areas, even the owner themselves, can go in there and make the connection to their hot water system, their storage device, and still have a perfectly functioning system without any risk to your investment. That's the big takeaway in my mind, having over 30 years of experience with these type of systems. You get the benefits of saving energy and saving money without the downside of potentially damaging refrigeration system. So in the next few slides, we're going to go through the process of things we take into consideration regarding how to properly size a system. Bigger, not always better. When we come to this, we're also going to talk about the maximum water temperature. In this demonstration, we're going to follow a sanitary model, and most sanitary cleaning operations require a washing temperature of around 180 degrees. In some of your businesses, that's way too hot. You don't need that. You may need that in your brewing process, but for a CIP process, you don't need it. So again, we can talk about that either online or offline about what fits your situation the best. But there's a lot of competitors out there that make claims on how much heat you can cover. The maximum you'll ever get is the temperature of the refrigerant, which in most cases is 160 degrees. But in reality, with line loss, temperature change, operating time, we think a safe number to talk about is 140. So you'll never see us quote energy or heat recovery greater than 140 degrees. The next thing is how much water do you need? And if hot water is important, higher temperature, then you don't want to oversize your tank. Again, that's where we can help you, and it's part of what we do to walk you through the process. And of course, now more than ever, any dollar you spend, your investors, and especially your banker are interested in what's the cost justification. Is it worth the payback? But beyond that, I think beyond the monetary payback, it's also important to discuss promotional image businesses around issues around your business. Are you perceived as a green, low carbon footprint supplier?
And we might have lost Steve's audio cue. Okay, I'm back and online here, so I'll kind of take over as we're going through this while we wait to see if Steve joins back in. So as we go through the justification tool on the system, uh, and what we're looking at is uh, the information that we'll capture on the front end is your location, what your water heating source is. That's important for us to know because as we're going through and helping with calculations for energy consumption, it's important for us to know if we're working with an electric water heating source, propane, or natural gas. Just like in some earlier presentations that have been on there, we talk about different efficiencies of systems. And so with a water heating source being electric, we would figure that being a higher efficiency, and the propane and natural gas being a little bit less. The other thing it's important that we are able to capture is what are your total hot water needs in the brewery over the course of a day. That's important for us because based on that amount of hot water that we're trying to generate, that is how we can establish a return on investment based on those the pounds of water that we're trying to heat up.
All right.
And it looks like we got
I was
Steve
sitting there
back.
talking. I
Steve,
didn't know I had left. So thanks for picking that up, Damon. That's why we got more than one person on the call. But yeah. So anyway,
yeah, you betcha.
Just to reiterate what he was saying, the source of your water heating is the biggest thing in this situation, the scenario. We're going to go through electric. Everybody has access to electricity. And again, the tank sizing is also something we'll cover, but it greatly affects how hot of water you can make. So a big thing to consider that we many times don't consider is what the incoming water supply is. If you're located in Phoenix, Arizona in the summertime, a city water tap will often be 90 plus degrees. That's a big negative when it comes to cooling things, but it's a big positive when it comes to heating your water source. Some of you in the upper Midwest that are on a well system, it's not uncommon to have 55-degree water. That's a greater load on your heating system to create hot water. So again, we talk about the size of the tank, but the amount of water that's going to drive what happens here that you can create is based on two things. Number one, the chiller load. Okay, how big a machine you have and how many hours a day it's operating. So those three things, how much you need. You could have a small microbrewery that may only have a 5 horsepower chiller, but
So it looks like I'll just pick up and keep running with this a little bit. So the chiller load of the refrigeration circuit is really what's going to kind of drive our amount of heat that we have capable to recover. And also what's going to be very important is what kind of a runtime per hour we're looking at on the system per day. Because with heat recovery, we're only going to generate and build hot water if the refrigeration circuit is running. So then we look at what kind of a maximum hot water temperature are we after, and where can we get to with the ProHeat 2.0? How warm can we preheat that water to? So in this example, we're using getting it to 140 and taking that hot water temperature down or up to 180 after that process of being the heat recovery's been in place. So then as we establish how much water that we're going to utilize in the facility, then we start to look at, okay, what is our electricity cost per kilowatt? And 18 cents per kilowatt is a pretty solid national average to utilize right now. The other thing we'll work with is how efficient is that? With electricity and electric heating element, we're looking at about 100% efficiency on that. With natural gas, that's going to be a lower cost per actual unit cost of energy, but our efficiency may not be as high. 80% efficiency is a number that we're utilizing. And from a propane standpoint, looking at propane at about $1.80 a gallon, that ties directly in with fuel prices. So as fuel prices have come down, so has some of the propane costs per gallon. But again, we're looking at about an 80% efficiency. I know there's other natural gas and propane heating systems out there that have higher efficiencies, and you've probably seen that with the exhaust piping material, not necessarily needing to be a steel pipe, but maybe being even in PVC, because those temperatures of that discharge gas has come down so low. So once we've established kind of our overall usage of electricity and what type of heat recovery capabilities we're going to have, then we start looking at what is our total cost on hardware. And like we said before, you know, getting the hot water isn't free. So there's going to be some installed hardware on the system. You're going to need an insulated storage tank. There's going to be some installation costs involved, and there's always going to be some of the miscellaneous materials. But for this example, if we look at Pro Heat 2.0 as an overall cost on this system at $16,000, then we break that down and say, okay, if that standard water heating cost, what is it going to cost us to generate that 1,000 gallons a day? So on a cost per day basis, we're looking at about $50.52. That's going from 65 all the way to 180. The cost per year on that, right, just over $18,000. And when we add in the Pro Heat 2.0 heat recovery system, that cost per day comes down significantly, because we're no longer having to heat from 65 to 180. Now we're able to heat only from 140 to 180. So then our cost per year that we're looking at that is just a little over $6,500, representing about a 64% savings versus not operating with the heat recovery system. So at the end of the day with that, we're looking at a total return of investment on the system of just a little over a year, 16.4 months, just to get that cost of that investment back. So that is a pretty good return on investment for a piece of equipment, and I think really makes heat recovery a justifiable scenario to explore inside the brewery. With that, I'm going to kind of open up right now for some questions and taking some questions. Look like we're still having some difficulties getting our other presenter online, but I'm really happy to field any questions regarding heat recovery at all. Looks like we've got a great one from Rob. At what level does this system make sense based on barrel size? Rob, that's a great question, and it's I haven't broken it down to actual barrel size yet. Be honest with you, I haven't had enough interaction with running some loads with folks on systems. I would say that any type of hot water recovery is going to be justifiable at any size, because it's recovering waste energy. So to me, that means any waste energy I can recover is going to be worthwhile. Depending on the size of system, I think carrying out that return on investment could look differently. Maybe at a smaller scale, maybe the return on investment extends out a little longer. But that's definitely something that our sales team would really be happy to go through with you, and we could run through some customized scenarios for you and establish that. I think that'd be a great one. So if you'd like to schedule a one-on-one or reach out to us, we'll be happy to help you go through that. Absolutely. This question comes in: Is Pro Heat 2.0 considered a green solution? I absolutely, it would be considered a green solution. Why? Because what we're doing is we're recapturing the heat energy. Like, you pay as a brewer to run that chiller system to generate that cooling and to strip that heat from the brewery. That all of that energy ends up being discharged just out into the ambient air. So by being able to capture some of that energy and reuse it, I think that's huge. I think we're absolutely a green solution. On top of that, also by having the Pro Heat 2.0 incorporated into the system, you get the ability to help reduce the load on the refrigeration circuit, the condenser portion. So not only are we generating some hot water, if we need a little extra assistance on the condenser load, we're actually able to do that with Pro Heat 2.0. And so that helps keep energy bills down as well, because as refrigerant discharge pressures go up, so do energy inputs go up as well. Great question. Can we reuse the heat that we're recovering to heat the brewery or the tap room space? Absolutely. So we talked about with Pro Heat 2.0, and as we recover that heat, being able to utilize that up to 33% of your rejected heat. So when we're putting that into your hot water system. So one way you can use it is if you're not consuming all of the hot water that's being generated, you could take that hot water and move it through other spots in the brewery. For example, if a lot of you have cold rooms where we use a glycol to air heat exchanger to cool the cold room, you could mount a heat exchanger and do the same thing with your heated water system. So now we're running heated water through the coil, and so we're actually heating the airspace. Another really good thing you can do with systems is you can take, and it depends on the type of system you have. With the V-Series systems, the condenser fans are actually able to have an external static pressure rating, and you can take some of that heat off of the condenser. This is the 66% that we're not able to recover, and when it's cold outside, you could divert that discharge air back into the facility and use that for heating some spaces. It's not gonna, you wouldn't be able to do much with it in the warmer conditions, but definitely during the wintertime, you'd be able to recover that heat as well. And that's aside from Pro Heat 2.0. Good question. This question comes in, is a modular system that can be added? Oh, is this a modular system that can be added, or is this a complete chiller package? Right now, at the moment, it is a complete package that is incorporated onto the chiller system. We are working on some developments to make the Pro Heat 2.0 system available as a modular style. But remember, one of the key things that is at the center of the operation of the Pro Heat 2.0 is that it is an onboard, fully contained piece of equipment. So, but that's a great scenario, Dean, and I think staying tuned over the next short-term period of time, we will be having some add-on potentials for that. Do you make a system which can capture air conditioning condenser heat into hot water? So we don't right now. No, what we have is just to have it incorporated onto the chiller system. But Richard, I like where you're going with that, and it plays right along into like your air conditioner's running and you're discharging that condenser heat. So most definitely, you're thinking along the lines with heat recovery. Like, geez, all these different places where I could now potentially capture that heat. That's good thinking. But yeah, unfortunately, I don't have that where I could hook it onto your air conditioning system. Is Pro Heat 2.0 unit expandable or able to add capacity? Yeah, the way we would if you had the Pro Heat 2.0 system on a existing chiller system, when the modular system was added, we would just be able to add the capacity to that, or add the Pro Heat 2.0 circuit to that to have it tied into the original unit. Hey, Steve, we got you back.
Oh yeah, it's a technical challenge, but that's why we got two people on a presentation, I guess.
That's right. That's right. So here's a good, are there tax incentives? Steve, I'm going to let you answer this question.
Yeah, that's there's a lot. Every state basically has its own incentive program. If you're interested in that, as odd as it sounds, your utility company is often the best place to go for that kind of information. They actually incentivize customers to use, particularly electricity, less electricity. There are also some programs, like in the Northeast, one called Focus on Energy, that is a very progressive program, very comprehensive, that addresses things like LED lighting. Pro Heat 2.0 would be a good example. Uh, all kinds of things. So if you're in the Northeast, that's a great resource. California has a energy efficiency program that is a renewable energy program that is world class, and certainly a lot of resources there. But I would start with your utility provider. Yeah, there's a lot of opportunities for rebates available.
Does adding Pro Heat 2.0 to the chiller affect the overall chiller operational efficiency itself as well? So I'll answer that. Yeah, what it does, and it will, where the biggest impact of the added efficiency to the chiller will be seen is when the ambient climate temperatures are getting up over 90 degrees Fahrenheit. Because what is happening is we're pulling out a third of the heat that the condenser would normally be responsible to take care of. So now we're adding that extra condensing capacity to the condenser. So that helps us keep that discharge temperature down, which equals less power input. So yeah, to answer your question, Andrew, it will help out with overall chiller operational efficiency. That's great. I think it looks like some of the questions have slowed down a little bit, but I think the questions that we had and had answered were all outstanding. I sure appreciate everybody getting questions coming our way. Here's one from Mike. Are there ways of utilizing the energy to use as electricity? I'm not sure I'm 100% clear on that. I'm guessing that you're asking if we can convert that hot water back to electricity, and that I don't know enough about electrical generation means to be able to answer that for you. That would be a bit out of my wheelhouse, if I'm interpreting that correctly.
Okay. Well, again, I would encourage everybody to schedule a one-on-one time, and you can do that at the VBC website, or go to prochiller.com for more information, as well as contact information for both Damon and myself. But despite technical difficulties, I think this has been a really good presentation, and it's a product that we're really eager to bring into the brewery segment. It's not available for all sizes of chillers yet, but that is something we're developing, and I think it's a great thing for the sustainability of the brewer business, both from a financial standpoint as well as a greater sustainability aspect for the planet. So thanks a lot, Damon. Do you have anything to add there in conclusion?
I think I would encourage everybody to any of the information we had in throughout the presentation. We also have that available on a landing page on our website. If you go to prochiller.com and select the products tab, and then go to the Pro Heat 2.0 option, that'll take you to the landing page that'll cover a lot of the things that I talked about in the mechanical side of the presentation.
All right.
That's great. So I appreciate everybody making it for this. Thank you very much.
Thank you, guys.
Okay.